Everyone. In this session of CCNA series, I will discuss SDN and controller based networks. Traditionally, network devices like routers, switches, and firewall are managed using CLI, command line interface, or GUI, also called graphical user interface. Those network devices actually can do a lot of things. They can be connected using cables or wireless to create a particular network. And to share the data across the network, the switches will forward it as Ethernet frames or router will forward it as packets. So they learn about different networks using different routing protocols. So everything a network device can do can be categorized into three different planes. For example, let's take a router. You can divide what it can do. uh, it can be categorized into three different planes: data plane, control plane, and management plane. So let's go ahead and discuss about those planes in brief. Starting with data plane. Data plane is also known as forwarding plane. The data plane is responsible for forwarding traffic. Anything to do with receiving data, processing data, and forwarding that same data, whether you call the data a frame, a packet, or more generically a message, is the part of the data plane. So the data plane is focused on the efficient and timely delivery of data packets. For those tasks to be executed as fast as possible, they are used. They use specialized hardware like ASICs and TCAM tables. Some of the most common actions that a networking device that fit into data plane is, for example, it can encapsulate and decapsulate packets, adding or removing 802.1q header, matching MAC addresses for forwarding, matching IP addresses, IP destinations in the routing table, changing source and destination address when you're using network address translation. And when you're using access link, either you can drop the packet or allow the packet. Those are the actions performed by the data plane. For the data plane to work smoothly, it will require some information to be provided. So like for routers, its routing table needs to be updated in order to send it to the destination. Or for the switch, MAC address table needs to be updated before it forwards a frame. So the action taken by the data plane totally depends on the information provided by the upper layer, that is control plane. So the term control plane refers to any action that controls the data plane. The control plane is responsible for managing and maintaining the forwarding information in the data plane. It is also responsible for network topology discovery or routing protocol operations and path determination between source and destination. And OSPF, there are a lot of protocols. OSPF is one of the control plane protocol. The other protocols are like RIP, ARP, EIGRP, and then BGP. Lot of routing protocols, you can say. The next plane we have is management plane. The management plane is actually responsible for device management and configuration on your device. It provides interfaces for network administrator to configure the device, monitor its operation, and troubleshoot any issues. So it includes protocol that allow network engineers to manage the device actually, such as the protocols are Telnet, SSH, SNMP, Syslog are some of the common management plane protocols. So now we know about how the traditional network operates, like what are the different planes. This is important to understand because when we go ahead and discuss about SDN, it will clarify everything. Okay, so with this, one thing that will come into your mind is traditionally network devices uses distributed model for the control plane, like protocols like ARP, STP, OSPF, EIGRP, BGP, these are the control plane protocols, are run separately on every networking device. For example, you have to configure OSPF on R1, R2, R3 so that they will share the routes. For example, as I said, like each router run its own OSPF routing protocol processes, and to make it work, those distributed control plane processes use messages to communicate with each other, like OSPF protocol messages between routers, as I said. And as a result, traditional network are said to be used distributed control plane. But starting from 2010, a new control, a new operational model was introduced called SDN, also known as Software Defined Networking. SDN makes use of a controller that centralizes some functions or centralizes the control of the networking device. So you will have a controller which will take the control of all the devices centrally. The degree of control and the type of control varies widely. For instance, the controller can perform all control plane function, replacing the device distributed control plane. Alternatively, the controller can simply be aware of the ongoing work of the distributed data, control, and management planes of the devices without changing how those operate. So here I have specific case where I have a controller, centralized controller, and a distributed data plane. If you see R1, R2, R3, they have a data plane and the controller is centralized. So the SDN controller could be either physical device or a virtual machine. And the controller can be located anywhere in the network where IP reachability of the devices, there is IP reachability to the devices in the network. Each of the network devices still has a data plane. However, note that none of the devices has a control plane. The SDN controller uses two special types of interfaces: NBI or northbound interface, SBI or southbound interface, which we will discuss in the upcoming slides. SBI, also known as southbound interface, here the controller directly programs the data plane entries into each device table using an SBI. The controller actually programs the data plane entries into each device using an SBI. So the SBI is the interface between the SDN controller and the network device such as switches and routers, which allows the SDN controller to but interact with network devices in order to update the data plane. So SBI is not a physical interface, right, but a software interface, often an API you can say, also known as application programming interface. So an SBI often includes a protocol so that controller and devices can communicate. But it often includes an application programming interface. In case if you do not know what an API is, it is a like method for one application program to exchange data with another application program. Like it is like an interface to an application program. So two programs, as I said, like one on controller, another on router, can exchange data using API. So in this case, in this topology which I have shown, where SBI is there, it is an interface between a program, that is the controller, and a program on the networking device, that is the router, that lets the two programs communicate, with one goal being able to allow the controller to program the data plane forwarding tables of the networking device. So SBI uses southbound API to move data between the controller and the networking device. So there are some common southbound interfaces such as, or you can say the protocols used by SBI, OpenFlow, Cisco OpFlex, CLI, Telnet SSH, and SNMP along, which is used for Cisco Epic EM, or CLI and SNMP along with netconf, which is used for Cisco software defined access. So let's go ahead and discuss about NBI. Now, how does the controller know what to add? Like before doing the program or giving the instruction to data plane. What kind of information would your program need to gather before it could attempt to add something like, for example, MAC address table entries or IP routes to IP routing table? This is where the NBI comes into the picture. NBI, also known as northbound interface. A controller's northbound interface will let you program its data and function, enabling network programmability with much quicker development. It is an interface that allows applications and services to communicate with the SDN controller and request network services. It refers to the interface between the SDN controller and the applications or services that want to interact with your network devices. An application can run on the same server as the controller and use an NBI, which is an API, so that two programs can communicate. In this particular controller happens to be written in Java and has a Java-based native API. The application can learn some information about the network by using the API. So if your app is here, the app is running on the same controller, so that's why it is using API within the controller. But what if your app runs on different server, like a remote server? Here the REST API comes into the picture. REST API, also known as a representational state transfer, describes a type of API that allows application to sit on different hosts, and it uses HTTP messages to transfer data over the API. The API needs a way to send the data back and forth over a network, so I would say RESTful API meets that need. Now we know what is SBI, what is NBI, what is what are the different planes of the router, and how the SDN works. So with this knowledge, we will move on to the next topic in my next session, which is about different types of controllers. Okay. I hope this was informative for you. Thank you for watching. We'll see you soon in the next session. Thank you.